Here's the last problem, and it's a doozy. It is very similar to question number 3, except it's flipped. Before, you had to find the acceleration and then multiply it by mass. Now, we're going to find the acceleration and go backwards to get displacement, but we're both using the VF squared. Just like question number 3, we use the VF squared formula, we're going to use it here. So the first thing we got to do is figure out, again, what's happening. So net force is equal to, well, there's no force applied. Nothing is pulling the truck. The only thing happening to it is friction. So force of friction on this side. So MA is equal to mu mg. What happens to the mu's? They cancel out. So acceleration is just going to be equal to mu times g, which is going to be equal to 0.75 times 9.8. And I believe you get an acceleration of 7.14 meters per second squared. Well, now we have to figure out what's going on. So 150 kilometers per hour. I'm a stinker. You got to convert that, and that's going to turn into 42 meters per second. So we have a velocity of 42 meters per second. Is that initial or final? Well, he's going 150 or 42 and then stops. So that's initial. V final, well, he stops. He's going to be 0. So I'm asking for how long. So I'm asking for displacement. All right, so what equation is going to work? The VF squared. Remember it? Okay, so we subtract VI squared from both sides. We have VF squared minus VI squared is equal to 2AD. We're going to divide both sides by the 2 and the A. Yoink, yoink. And we get D is equal to everything on that side. Plug in our numbers, chug away and get your answer. And we're all done with force and friction.